Okay, so now we come to early 20th century. And in the early 20th century, around 90, was it 20? No, that was 1932, I think. In 1932, physicists had, I have to check this number, but physicists had formulated a theory which they called quantum mechanics. They've been working quite a few decennia of this theory. It was very tricky to make it all fit together, as you say. And what physicists discovered was that, well, it's you still have like this smallest element, but it's not a thing. That's what they concluded. Actually, it's nobody knows what it is. That's what they concluded. And they concluded this in a famous conference in Copenhagen in 1932. And there was something that was called the Copenhagen interpretation of quantum mechanics, which basically means like don't interpret the math at all. And I'm going to explain the reason for why they said don't interpret the math. The thing is, like, physics is about observing things. So if you have something here, let's say is a box here, then you observe something here, and you observe it at some time. Let's say you observe it 12 o'clock. Okay? And you observe it to be here in the box at 12 o'clock. Then you go away doing your things, and then you come back, let's say 1 minute past 12. And then you see the thing is over here. This is your first observation. This is your second observation. Now you can start to ask questions here, like, how did this thing get to that place over there? That's a question you can ask. One way to answer that is to, for instance, has been at 12:0 plus 30 seconds. So halfway in between these times, you could have come there, and for instance, maybe you observed it to be here. Okay, but the question still arises like, okay, so we know that in between here it's been here once, but how did it get from here to here and then from here to here? Well, again, you could come in 15 seconds after 12, and maybe you observe it here, and then you could be at 45 seconds and you observe it here. The point I want to make is that physics talks about things you can observe. Okay? So you observe something here, and you can't say anything about this thing unless you observe it. In between here, in between 0 and 15 seconds and 30 seconds and 45 seconds and 1 minute, in between here you haven't observed anything. So you can't say that you know what's in between here. But it's reasonable to assume that it's probably been something like this. So it means it has gone in a straight line. Right? It's a reasonable assumption. Assume it. But you can't say for sure, because it's still like an assumption. Quantum mechanics is about, as anything else in physics, is about observing things. But the thing with quantum mechanics is that you don't observe. If you say this is a ball, it means you observe the ball. It's an object you're observing. In quantum mechanics, you don't observe objects, you observe events. So you observe an event here. At 12. And then a minute later you may observe that event here. And you could do the same observations here. Yeah. So you have all those events you observe here at 0, 15 seconds past, 30 seconds past, 45 seconds past, and 1 minute past. And when I say event, what does that mean? I mean you observe a position of something. And when I say you observe a position, I want you to remember this, that a position is the only thing you can observe. You may have heard about that quantum mechanics is like a wave theory, that matter is either a wave or a particle, blah blah blah. I wouldn't go so far to say it's bullshit, but it's misleading, because the only thing we ever has observed is a position of something. Now, the way we observe these positions, I'm saying we, like I've been doing it, I mean like humankind, physics among humankind, the way these positions has been observed in quantum mechanics doesn't allow for an interpretation of straight paths like this. And while you can assume this for a ball, and if you do that for a ball, you won't run into any incoherent stories or contradictions. But if you try to interpret those positions you observed as something has been traveling in a straight path like this, then you will run into a problem in quantum mechanics. I'm not going into why that is, I'm just saying that this is how it is that this problem exists.